All right, so in question 13, it says find all the critical numbers of this function. And because this has a 2x in here, we're going to have to review something back from pre-cal. But you have no chance at all getting this question right if you don't know what a critical number is. So critical numbers are things that make the first derivative 0 or undefined. Critical numbers are often going to end up being extrema, but they're not guaranteed to be extrema. So that's kind of the basics you have to know about critical numbers quickly. So really, to answer this, I just need to figure out when is the first derivative 0 and undefined. That's all it's asking. So the derivative of a constant is 0. The derivative of sine something would be the cosine something. And since the inside part doesn't have a derivative of 1, I would need to multiply by the derivative of the inside, which would be 2. So it looks like the derivative, cleaned up, would be negative 4 cosine 2x. Everybody okay with where I'm getting at? Make sure that you got the chain rule in here. Okay, so where's that undefined? Well, luckily that's not too bad. Cosine's never undefined. Think about what the cosine graph looks like. You know, it's a continuous, nice continuous wave. There's no holes, there's no asymptotes. Cosine's never undefined. So really the challenge to this question, because taking the derivative, like I know that's new to you this year, but you can see I could do that quickly. I can't so quickly figure out where this equals 0. And this is actually something that we're about to do in pre-cal as soon as we come back from Thanksgiving break. So you could divide both sides by negative 4, and that moves you a little bit closer. And you could probably guess and check some answers. You could probably think about, like, what could I plug in times 2, take the cosine of that angle and get 0. The problem with that is, even if you come up with some, you may not come up with all of them. I guess if it's multiple choice, though, to be honest, I would probably just start plugging in, checking. See which ones work. That would be the quickest. But to practice doing this algebraically, how I would ask you to do this in a pre-cal class is I'd say, well, pretend for a moment that this doesn't say 2x, it just says x. So when is cosine 0 in one revolution? Well, cosine 0 when x is 0 on the unit circle. So that would be like when x is pi over 2 plus multiples of 2 pi. That makes sure you get all the coterminal angles. And when x is 3 pi over 2 plus everything coterminal. So this is like a formula that helps you find all the answers to that. But the problem is, I didn't really solve for x, I solved for 2x. So you have to go back and say, all right, well wait, there's one more step. I'd like to divide this by 2, so this gets divided by 2, and this gets divided by 2. So now its formula says pi over 4 is an answer, plus integer multiples of pi. Do the same thing here, divide by 2, divide by 2, divide by 2. This formula is saying 3 pi over 4 is 1, plus integer multiples of pi. So pi over 4 is certainly an answer. 3 pi over 4 is going to be an answer. But if you don't keep up with that formula piece, then you're going to lose some of your other answers. And as multiple choice, I'm sure that there's a choice that only has those two. So this says you should be able to add 1 pi or 2 pi or 3 pi, any integer multiple. Well, if I added 1 pi, that would be halfway around the circle. So it looks like 5 pi over 4 should also be an answer. And this is saying 3 pi over 4 is 1, but add pi should give you another one. So adding pi would be halfway around the circle. And the question says give everything between 0 and 2 pi. So all of these angles are between 0 and 2 pi. So I'd say there's 4 solutions. Now again, realistically, multiple choice, you see options, like you don't have to solve it algebraically. It would be kind of a time waste to do that. But if we don't practice doing it algebraically, then we're never going to remember how to do that. So I'm sure on a test there'd be a little bit of a shortcut. But okay, follow-up questions for this one, number 13. Do you guys remember doing that in pre-cal? The solving the equations, the plus 2 pi n, all that kind of stuff?